This is our video for Unit 7, Day 2. So today we're going to talk about some congruence theorems for triangles. That's going to build off what we talked about yesterday in terms of similarity and congruence. So first thing, if we have two triangles that are congruent, that means all three sides and all three angles, all the parts of the triangle, are congruent. Yesterday we were looking to see if triangles were congruent. We checked all six parts. We checked all three sides. We checked all three angles. Today what we're going to learn is 5 shortcuts, right, which are called theorems or postulates. Right, that allows us to tell if a triangle is congruent to another triangle without having to check all 6 parts. In each of these triangles, all we're going to have to check from now on is just 3 parts. So the first one of these theorems, or these shortcuts, is called side, side, side. So this theorem says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. Means all 6 parts, so all 3 angles and all 3 sides. So here's an example of side, side, side congruence right here. If we look at these 2 triangles, what it gives us, the information is that side KA is congruent to side DF. It also tells us side AO is congruent to side FE. And tells us side OK is congruent to side ED. So just from that information, checking that the 3 sides are congruent, we can already say the whole triangles are congruent. Say triangle AOK is congruent to triangle FED. And next to it, we write side, 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 because that's what we use to show the triangles were congruent. So once we know these triangles are congruent, we now know that the other 3 pieces we didn't check, which are the angles on this one, are congruent as well. So we've used this shortcut to show these triangles are congruent, and now we know that everything else between these 2 triangles is congruent. So we know that angle A now is congruent to angle F. We know that angle O is congruent to angle E. We know that angle K is congruent to angle D. Once we know that triangles are congruent using one of these shortcuts, we know that all the pieces are congruent, all 6 parts. Our second shortcut is called side angle side. This theorem says if 2 sides and the included angle included angle means the angle in between those 2 sides. So if 2 sides and the included angle of one triangle are congruent to the 2 sides and included angle on another triangle, then we know both triangles are congruent to each other. So not just those 3 parts we checked, but all 6 parts of the triangle. So same idea here. The given information, we know that angle B is congruent to angle M from the picture. We know side BO is congruent to side MN. we know that side BR is congruent to side MA. So this gives us two sides and the angle in between. So two sides and the included angle. So this theorem tells us now is that these two triangles are congruent. So triangle BRO congruent to triangle MAN. Right, and the reason is side angle side, so we put SAS in parentheses next to the congruence statement. Again, once we know using these three parts that the triangles are congruent, that means the remaining three parts of the triangle are also congruent. So we use side angle side, and now we know that angle A is congruent to angle R. We know that angle N is congruent to angle O. And we also know that the remaining side we didn't talk about yet, side OR is congruent to side AN. We're using the correct order side NA. So once we use one of these shortcuts, we check three pieces, we see the triangles are congruent. That means the remaining three pieces of the triangle are also congruent because the whole triangles are congruent. So I have three more shortcuts. This next one's called angle side angle. So this is like the opposite of side angle side. If two angles and the included side, again that means the side in between those two angles of one triangle are congruent to two angles and the included side on another triangle, then we know the two triangles are congruent. And not just those three pieces we checked, but all six pieces that make up the triangle. So same idea here as the last one. We see that angle R is congruent to angle B. Angle D is congruent to angle U. And that side UB off the right triangle is congruent to side DR off the left triangle. So that gives us two angles and the side in between. It's angle side angle, so we know these two triangles are congruent. So our congruent statement, triangle RED, match that same order on the second triangle. R corresponds to B, E corresponds to L, and D corresponds to U. So triangle RED is congruent to triangle BLU. And we give our reason is angle side angle. So we'll put ASA in the parentheses. Just like before, we now know the remaining three pieces of the triangle that we didn't check are also congruent because of this shortcut. So we know that angle E is going to be congruent to angle L. We know that side LU will be congruent to side ED. And we know that side RE will be congruent to side BL. So the next one's very similar. Next one's called angle side angle. Or sorry, angle angle side. So this is similar to angle side angle. The only difference is now that side is not in between those two angles. It's not included in between two angles. So we have two angles and a non-included side. Right, so it's not in between the two angles. So if we have those pieces matching up on two triangles, then again, the two triangles are going to be congruent, and that goes for the whole triangle, so all 6 parts of the triangle. It's not just the 3 pieces we checked, those 2 angles on that side, but all 6 pieces of the triangle. So just like this one here, the given information tells us that angle F is congruent to angle D, angle R is congruent to angle A, and then it tells us that side RI is congruent to side AY. So that's enough information for us to say that these two triangles as a whole are congruent. So triangle FRI congruent to, matching the same order, triangle DAY on the right, and the reason we give for that is angle side. So once we check those 3 pieces, we know the triangles are congruent. We know the remaining 3 pieces are also congruent. So we know that angle I is congruent to angle Y. We know that side DY is congruent to side FI. And we know side AD is congruent to side RF. So just by checking those 3 pieces that fall in particular order, we know that all 6 pieces of triangles are congruent. So this last one is a special one that's only used for right triangles. And this one's called hypotenuse leg. This one says if the hypotenuse, which is the longest side of a right triangle, and one leg, which is either of the 2 shorter sides of a right triangle, are congruent on 2 different right triangles, then we know those 2 right triangles are congruent. And again, that means all 6 pieces of the triangle. So even though it's called hypotenuse leg, we're still checking 3 things. We're checking the hypotenuse, checking the leg, and we have to make sure that it's a right triangle. So this is only for right triangles. So the longest side on a right triangle is always across from 90-degree angle. Right, that's the hypotenuse. Then either of the 2 shorter sides are called the legs. So that's what we see here. We see we have right triangles because angle Y and angle T are both right. Both right angles, 90 degrees. Right, then we see the hypotenuse are congruent. That's DR congruent to WE. And we have one leg, DY congruent to WT. So now checking these 3 pieces, 1 that it's a right triangle, 2 that we have the hypotenuse congruent, and 3 that we have 1 pair of legs congruent. We now know the triangles are congruent using the shortcut. So I can write my congruent statement, triangle DRY is congruent to triangle WET, and the reason HL, hypotenuse leg. And again, now we can go back and name all the other pieces of these triangles that are congruent. We know that angle D and angle W will be congruent. We know that angle R and angle E will be congruent, and we know that the missing sides that aren't labeled right now, side YR and side TE, will also be congruent. So these are the 5 congruence theorems or congruence postulates that you'll see on the Unit 7 test. This is the way we check to see if triangles are congruent. We don't have to check all 6 pieces. We only have to check 3 particular pieces. So these are called triangle congruence theorems. Or postulates. So if you're looking for a different video or some extra practice problems or something else to help you with this, it's what you can search for: triangle congruence theorems or triangle congruence postulates.